appear on your screen. I just said to some people in the chat that I've been teaching in Bangkok over the weekend, and I'll talk a little bit about that. But as I've been doing that online teaching, so I've been teaching based in just north of Leeds in the UK, online to a large group of teachers in Bangkok, and it's been interesting thinking about this webinar about assessment and assessment with primary age children, and the way that I was working with teachers, and that a lot of principals are the same. There you see me in a classroom in Jaipur in India. The thing it says on my Twitter handle is I'm a mathematics teacher and a teacher of teachers of mathematics. And that kind of sums me up, that I still enjoy teaching mathematics. The thing I like doing most in the world is teaching mathematics, particularly to fairly young children. But I enjoy teaching mathematics to everybody. And I kind of enjoy teaching mathematics to mathematics teachers, because I think one of the things that makes our teaching better is our own study of the subject that we teach. But most of all, I enjoy working around the world, because that's where I learn most. I learn most when I'm sitting with kids in a classroom with India, or talking to teachers in Bangkok, or talking to groups of teachers like this from all around the world. And I think one of the things that has come out of the pandemic, which is a positive thing, is the growth of webinars, where actually what we do is we learn from colleagues all around the world, rather than colleagues just from our own little context. So I'll leave that. Bob, if you introduce yourself, and then what we're going to do is I'll talk about maths assessment for about 25 minutes. Then Bob will have 25 minutes on science, and then we'll have about 10 minutes of questions at the end.
Thank you, Tony. Hi, everyone. I'm going to say very little at the moment. Yes, that's a photograph of me working with a school in China. And I've been a science teacher and a university educator for many years, and now retired, but work with Macmillan Education on international projects. And it's been a real pleasure for me to travel around the globe and, rather like Tony, meet people and see places. But I was reflecting the other day that although I've been lucky to go to many places, what really gives me a lasting warm glow and memory are the people that I've met. And I've been so lucky to have met such fine teachers and have had such happy times. So I'm looking forward to that. In the fullness of time, maybe next year, when we'll meet again in the flesh, and we'll enjoy some teaching and learning and cups of tea and biscuits together. So I'll speak to you in about 25 minutes, but I'm looking forward to listening to Tony. So thanks, Tony, and we'll speak again later.
Yes, see you later, Bob. So we'll start off thinking about assessment and primary mathematics. I think really what both Bob and I are going to talk about is assessment in general, and then what we'll do is we'll pick out examples from mathematics and from science, because the principles of assessment are the same whatever subject we're teaching, indeed whatever we're teaching. And what I'll also try and do is think a little bit about how we can put the principles into practice remotely, as well as when we're working face to face. And I think that's something that I've been particularly thinking about this weekend. You'll know that when you're about to teach something, all the teaching that you do before enables you to think a little bit more about what you're going to be teaching. So my teaching over the last 2 days about training to teach basically has actually focused my mind on assessment in primary mathematics as well. But one of the first things I want you to do is just I want you to reflect for a moment for yourselves, and then type in the chat just a brief sentence about the last assessment you carried out in a mathematics lesson. And I just want you to type that in one sentence, because it's the chat. When was the last time you carried out an assessment in a maths lesson, and what form did it take? It's always good when you can see the "someone is typing" icon coming up. it's always quite useful to clarify terms at the beginnings of things. So it's useful to know what's in your heads when you think of assessment. Thanks, Nina. 2 weeks ago, Nina, a pencil and paper test. Other people, what your last assessment in mathematics? This is where ClickMeek is sometimes a bit clunky because it takes a while for comments to come through. Anybody else? 3 years ago, pencil and paper, 1981 end of topic test. Well done, Bob. Anybody else? So that's three pencil and paper tests. While we wait for this, whoever the next someone is, would it be nice if it, instead of someone, it gave us somebody's name? I've had several jobs training teachers in 3 different universities, yeah, and I would have to go and observe trainee teachers. And quite often they'd say, Tony, it's not worth you coming into the next lesson because I'm doing a test. And there would be a sense that it was a complete waste of time me being there, because all I would be doing is sitting at the back of the classroom whilst students were sitting silently working on a test. And that's kind of what was in everybody's mind in terms of assessment. There we go. So Humbert's thinking of maybe a different form of assessment, on counting sets using pencil, paper and objects. So there's something going on apart from sitting with a pencil and paper. I wonder if, particularly in mathematics, people see assessment as that paper and pencil test, and whether we see assessment as a paper and pencil test because that's the form that high stakes tests take. And high stakes tests in mathematics are particularly high stakes because they may put us into different teaching groups. They may offer access to universities. In the UK and in other countries, you can't get into universities without having a mathematics qualification. So to do almost any degree in a university, you'll probably need a grade C in GCSE, which is the 16 plus test. And you certainly can't become a teacher of anything without having your GCSE in mathematics. And Manu has predicted the next bit, which is the difference between formative and summative assessment. So we tend to see the summative assessments, the paper and pencil tests, as higher priority than the formative assessments. 2 examples of assessments there that my grandchildren carried out. It's great to see things coming through on the chat now. So kind of keep your eyes on both of those places about the different sorts of assessment that you're doing. The assessment on the left-hand side is from my grandson Felix, age 8. And what he now sees as assessment is his Friday afternoon test. You can see it says arithmetic test. That's another English word for assessment. So he knows it's an assessment. And what I was quite interested in, he seems to spend more time doodling on the front cover. So he's doodled around the addition, the multiplication sign to make quite an interesting pattern. He's turned the subtraction sign into a little robot, and he's drawn a car all around the subtraction sign. In case he was left in any doubt about what mathematics is, there's useful 4 and a 5 and a 3. So he's been given the impression that mathematics is just about operations on numbers. So even at age 8, he's being given this sense that mathematics is about this sort of a test and about numbers. At age 3, Tate was given a slightly different view of what assessment might be. So there he's creating an image of 5, as many different images of 5 as he can possibly make. So it's an equivalent of Marina's assessment. Marina asked parents to send a video with children counting bottle tops. So she gets a really good sense of what her children's abilities in terms of counting are. She knows particularly she's looking for one-to-one correspondence. So she's checking whether or not the children are pointing at the objects when they count them. She can give advice to the parents about how they might support their children, all from that piece of assessment. We can see from Tate's assessment, or the teacher can see, that he has got different images of 5. He's starting to notice that 5 is the same as 4 plus 1. If we look at that image on the left-hand side, 4 stones in a pattern and 1. He can put 5 sticks in a line to create 5. I can see a 3 and a 2 in terms of buttons, and another 4 and a 1 with shells. But that image, he's chosen to do that as he's rotated the first image through 180 degrees. And I can even see how his writing's coming on. Can you see Tate's the top left-hand side of the image? So how much more information we get out of that as an assessment than we get from Felix sitting quietly on his own, completing that mathematics test. Now, in some ways, they're both pieces of summative assessment. So Tate could have been doing lots of activities about the number 5, and that can be a piece of summative assessment. But because it's active, because it's using objects, I actually end up getting more information than I got from Felix's test. So just a quick revisiting of what the terms might mean. Summative is your paper and pencil test that you've been telling me about, often written, but it can be an observation or a conversation. So Marina's test of a video is also summative. She's finding out how well children can count from 1 to 10 or from 10 to 1. So, and the record might be writing. It might be a photograph, like the photograph I showed you of Tate's. Marina's given a great example of a recording. So all of those are summative assessments. And it might be part of high stakes systems. They're often summative style assessments, the high stakes assessments. High stakes means it's important, means the results are reported to parents, to governments. They're used to make decisions about maybe the next group that children go into, or the next school that children can go to, or universities that students can go to. And we often share summative assessments with parents. And parents are often interested when they say, how well are they doing? We might well share a summative assessment with them. Formative, as Manu said, takes place on a daily basis, and it's the stuff we do every day that helps us think about what to do next. So I said that whilst I've been teaching a PGCE over the weekend, I've been thinking about this teaching. So in a sense, I've been using formative assessment on those students. How well are they understanding what's going on here to help me in my decisions for today? Also, for those students, it also in terms of thinking about Tate's photograph as a formative assessment, what do I need to do next? He could perhaps explore, has he got all the different ways of making 5? He could explore how he might record those ways of making 5. We often don't record that formally. Sometimes we just keep the information in our heads as we move forward in planning. Sometimes we keep the information in a notebook. And we often don't share that with parents. I wonder if sometimes that's why in our heads we see summative assessment as more important, more higher status than formative assessment. Maybe if we shared some of the formative assessments with the parents, we would see that as important as summative assessment. So the only reason I've got that photograph of Tate's work is because that was shared with his parents, with my daughter and son-in-law. So I have that as evidence of what Tate's learning is. Dylan William, and that is the correct way of spelling his surname. Nothing annoys Dylan more than putting 2 L's in his surname. He is Dylan William. One thing does annoy him more than that, and that's calling him Dylan William, which I do whenever I come across him. But Dylan William wrote a book with Paul Black called Inside the Black Box. And in that, there were 5 principles of assessment for learning, which is another way of talking about formative assessment. And that's mainly what I'm going to focus on in the next 10 minutes, is just unpicking this diagram a little bit. And you can see that there are 3 people involved in assessment and 3 purposes for assessment in that grid. So as well as teacher and student, which are the people that we would perhaps normally assume were being involved in assessment, there's also our peers. And if we think about that, that is the case, isn't it? We often use peers even now in terms of assessing ourselves or getting them to support us in our assessment. Peer assessment is whenever we ask somebody, how do you do such and such a thing? That's peer assessment. That's being supported by peers. As we were working over the weekend, it was a blended learning course. So it was part of the reason that we had to get up so early in the morning is that some of it was direct inputs from us to the group of students. A lot of it was them going into breakout rooms in Teams. Teams was the platform we were using, at which point they were supporting each other. They were comparing their ideas. They were developing their ideas by talking to peers. And the 3 purposes for assessment is that we can be clear where the student is going, and that's particularly important for the student. But all 3 people in the room, the teacher, peers and students, all need to know where the learning is going, where the student is now in terms of their thinking, and how is the student going to move forward in their learning. So those are the 3 purposes for assessment. And you see from the grid who's involved in those three different types of formative assessment activities. So let's start to think about clarifying, sharing and understanding learning intentions. That's about knowing where the learning is going. And that's a page from Max Maths. So Nalia, hi, who's just come in, and Humbert will recognize that page. And what you can see there is the introductory page to a unit on patterns and a set of learning objectives. So the teacher and the student know what's coming. In this unit, you will learn to create a 2-dimensional pattern design using only pictures. It isn't formative assessment if all you do is read through a page like that. Because how do you know that the student actually has understood where they're going? How has that helped the student understand the learning intentions? So what I would always be doing with a page like this is I'd be working on a group activity. So on that page, we would be looking at triangle numbers. We'd be starting to look at how those patterns were formed. I'd be getting the students in groups to create those patterns. I'd also look at the learning objectives, and I might pick out key vocabulary. So I might pick out words like 2-dimensional, odd and even, prime and composite, series, missing elements, triangular numbers. So there's obviously some key vocabulary there. And an activity that I quite often use is saying to the students, in groups, I want you to draw or write a definition of these key terms, because that also helps me understand where the students are at the moment, what their understanding of terms are. And we can then create a display with their definitions of those terms, which we can add to as we go along. So that's done 2 things. It's allowed me as a teacher to know what their current understandings are, and it's allowed me to clarify what the meanings of those terms are so that they can properly understand what the learning objectives are. Eliciting evidence of learning was the next thing in that grid. Sometimes that's the same as a summative assessment. So you can see on the right-hand side what looks like a multiple choice. Well, it is a multiple choice grid. It's labeled what do I already know, though. So it comes at the beginning of a unit rather than at the end of a unit. And what I would do with that is I'd get the students again working in groups. And what they will be telling me is how they know which the right answer is and explaining their strategies. Because that elicits evidence of learning better than them just sitting quietly on their own. Let's practice. So this is a practice activity. Write the word. So you need to write a description of an equilateral triangle, an isosceles triangle, an obtuse triangle, a right angle triangle. And then the next question, write 2 ways to identify an isosceles triangle. So we're trying to go a little bit deeper in terms of thinking. It's not just complete a test like the one that you saw of Felix's at the beginning. It's asking students to think a little bit more. And if they're thinking a little bit more, and often they can think a little bit more by trying to explain something to somebody else, we hear what their learning is rather than just noticing some words on a page. And that's real evidence of learning. Activating students as learning resources for each other is just a fancy way of learning from your peers. So Vygotsky talked about learning socially, that the way we learn is through social interaction. That's Dylan's way of saying we learn through social interaction. We learn through working in groups. So whenever you can, ask students to be working in groups, because that's how they know they learn from each other. And I think one of the other important things to notice there is if your students are working together and talking to each other, you're again getting good information about their understanding by hearing how they explain something to somebody else. Again, something you know as a teacher is that you learn a little bit more about every subject every time you teach it, because you have to clarify your thinking in order to be able to explain it. One of the assessments with the teachers that I was working with over the weekend, and this is the master's level, is that they have to produce a presentation on learning theories. And they send us a presentation, them talking about it. It isn't a written assignment. And one of them said, "Isn't that easier?" And I said, "No, I think it's harder. I think I can tell more easily whether or not you understand the theory that you're talking about if you're trying to explain it to me on a video than if you write a paragraph in an assignment. So I think I know more about whether a student understands some mathematics." So there on the right-hand side, you can see working out how many different rectangles you might be able to make with an area of 24 square centimeters. Working in a group and listening to people doing that gives me lots of information about what those students understand about area and allows the students to learn about area from each other. Activating students as owners of their own learning. That's to do with getting students to take responsibility for their learning. So that's one part of it. And also being able to reflect on their learning so that they can think, how can I apply what I've learned in that situation in a new situation? In the Max Maths journals, there's a traffic light system where it says, think about what you've learned and give yourself a red, an amber or a green. Probably quite a lot of you use that as a form of, and that is formative assessment. It helps you understand how much the students have understood. Now, of course, we need to train our students to be able to use that effectively. So often it's better asking them to write or explain to you why they're saying that's red or why they're saying that's orange. And one of the things that's really important is we probably have to give permission to students to say, you know what, Tony, I really didn't understand any of that. Because often students will pretend they did understand it because, of course, they want to get 10 out of 10 in their test. They don't want to say, I didn't understand any of that. And that's all part of getting students to take control of their own learning. And then the final part of formative assessment is us as teachers providing them feedback that allows them to move forward. So through the formative assessment process, we've come to understand what it is that they know at the moment? How do we move them forward? And there's some questions that I've found useful to move students forward. What did you find easy in the last 3/4 of an hour? What did you understand? What do you remember from your previous experience? We could do this with the previous 25 minutes. What's made absolute sense to you? What did you already know? You will know quite a lot of this stuff. Is there anything there that you thought, oh, I'm not sure whether that would fit in my classroom? What could you do to maybe adapt your classroom so there is more formative assessment? What might you want to go and learn more about? Maybe you might want to go and find out more stuff that Dylan Williams written, and so on. So that's the sort of feedback that we can then provide learners so that they can move forward. So maybe if I was to say, describe the last time that you carried out an assessment in a mathematics lesson, now you would perhaps think about simply the last lesson that you taught on all of the ways that you'd been assessing formatively during that lesson. There's a blog that goes alongside that, and that's I kind of extend these ideas a little bit and talk a little bit more about summative assessment too. But for now, I'll stop there and hand over to Bob. So I've taken 2 minutes longer than my 25, Bob, but then we took 2 minutes introducing ourselves.
Thank you, Tony.
Pleasure.
And hi, everyone. I'm going to support much of what Tony has said, but in a science context. And I'll move through these slides as swiftly as I can. And there'll be time towards the end, I would hope, for some questions and some discussion. So here we go with assessment in science. Now, firstly, I'm going to welcome you from sunny Scotland. It is, in fact, a day just like this, a fine autumn day where I am at the moment. I'm in my home in a place called Kibble, just south of Edinburgh. And it really is this beautiful. And I'm very lucky to be here. And I hope one day some of you listening will have a chance to travel over to the UK and visit Scotland and see some of the beauty of our countryside. Just in the way that I've been able to travel around the world and see some of your homelands. Today, I want just to have a look at 3 areas involved in assessment. I'm going to tackle these 3 sections, and we'll see how it might marry with some of the messages that Tony has given. So we'll have a look at, in general, assessment, and then we'll have a look more specifically at science. So here's a question for you, just like Tony's question. Perhaps a harder one. Have you ever thought, why do you assess? It's quite critical. We spend a lot of time assessing. Well, what's the purpose? If you were sitting with a group of teachers, you could have a discussion on this very topic, and it could last you half an hour. I'll save you the trouble of digging out friendships and spending a long time on this question today, because I've got a few answers ready up my sleeve. Here are a few that you might be thinking of. I'll give you a moment to read these. Some of these comments resonate with what Tony has said. The teacher that said, I want to know what learners already know. What is their prior learning? Where do they start from? Do I need to reinvent the wheel? Or can I base my teaching today on something that's secure already? Of course, there is always an outside influence on assessment. Someone wants to know how well my class is doing. Are they grading the students? Are they grading me? Maybe they're employers, maybe they're university people. Parents may want to know, as Tony suggested, exactly how is everyone doing. Maybe you're proving that you're doing a good job. Or maybe, as the lady in the yellow dress is suggesting, that the purpose is actually to help learners set their own targets and take more control of their own learning. there's a dozen ways of thinking about the answer, why do we assess? And we'll have a look at a few today. Tony mentioned this high stakes assessment. This has been the assessment that has really been a feature of school teaching for the last 50, 60 years. It's where you leave your school with a certificate and you're described as a 2 A's and a B student or a 3 B student. Someone says, how did you get on with your A levels? Well, I've got 2 B's and a C. Well, that's really the way that this summative assessment might well describe you when you leave school. And it's your passage to the future, or maybe not to the future. But here's a question. If you get a grade C on an end of unit assessment or an end of year or an end of school assessment, what does that really mean? It might mean you scored 50% on a test. Well, okay, that's jolly good, well done. It also meant that you didn't score 50%. So does it tell you anything about those topics you're not very good at or the questions you couldn't answer? Not at all. Even a grade A, you could score 70% and be awarded grade A. And what about those 30 missing percentage points? Does it give you any chance of recovering those? No, it's too late. And that's the second problem with summative assessment. It's too little, too late. And there's very little chance to go back and relearn or revisit those topics which you're a wee bit uncertain of. But sadly, much of our assessment, even today, is based on summative high stakes assessment. And it just doesn't give you the chance, a second chance to go back and try again. And that's one of the great weaknesses of summative assessment. Okay, so here we are in one of our modern classrooms, and there's Miss Helpful. And is she teaching? She's just watching, listening and learning. And she's listening to the conversation between this group of children. And what she's doing is she's engaging in a bit of formative assessment simply by watching and listening. And she can tell that Sol can explain the water cycle, so can Jasmine, but Jack is struggling. Now that's just simply by Miss Helpful being observant. She's gaining evidence, but she's just drifting quietly in the background. Well, she takes action. She'll invite Jasmine to do some explaining herself. Jasmine becomes the teacher. In formative assessment, learners can become teachers, and teachers will be learners. Miss Helpful is learning about her students. She's listening, observing, she's gaining evidence, and she's taking action. And I call this action intervening. And I'd encourage you all to be much more interventionist in your teaching. It's not enough in science lessons to give out 20 rulers and collect in 20 rulers at the end and make sure that everyone is busy with a pair of scissors or doing whatever they're doing with the measurement. That's not enough. Your job is far bigger than that. Your job is to listen, to watch, to intervene, to steer the learning. And that is what formative assessment is about. It's assessing for learning. You assess because you want to shape and push forward the learning. So that's Miss Helpful intervening. Here's the aforementioned Professor Dylan William. And I've just lifted a few of his very interesting quotes. Because the first sentence here is quite interesting because he's talking about students and teachers learning. And he's talking about feedback, how you might use signals to intervene in the teaching, and how you might make adjustments to your teaching in real time. This is reflecting in practice. It means that you are always constantly thinking about how you are doing with regard to how the students are progressing. So it's a very dynamic process, and you are in the middle of it, intervening. So Miss Helpful knows, because she's been on one of these training courses, that that's exactly what she was doing. So just close the first part of this presentation. As Tony suggested, formative assessment and summative assessment, quite different characters. With summative assessment, usually it's at the end of a process of learning, maybe the end of a topic, maybe the end of a year, or maybe the end of schooling. And it may say very little at all about anyone's achievements. Formative assessment, on the other hand, is interwoven with your teaching. It becomes part of your teaching style. It's not something that's added to your teaching, it is your teaching. And because it happens in real time, it's never too late. So to finish this brief introduction, these are some of the things I would wish you to take away from my messages. The purpose of formative assessment is to help both you and your learners. They're partners in this process. It does help you teach because it helps you modify and make your teaching more effective. That's reflecting in practice. That means that as learning happens, even small steps of understanding a word, a meaning, a diagram, can be celebrated as the learning takes place. That's motivational. The responsibility for monitoring is not just with the teacher. Children enjoy knowing where they are and thinking about their own targets and talking about them. So it's not something you do at home when you take the marking home and you secretly mark test papers. And it helps finally that you actually realize that actually your role is partly as a learner, and for learners, they can be teachers of each other, and they can teach you. Listening to how a student might explain something in a way that you've never thought of is a really powerful way that you can reflect on your own teaching and learn to do something differently. So, okay, we have mentioned Max Science before, and I was very lucky to take the lead in the team that wrote this course. And let's take a look at a few examples from Max Science. Here I am in a Max Science classroom, and as Tony mentioned, group work is critical. I call this active learning in a social setting, and tables and chairs become incredibly important. How you arrange them is quite important to shape the learning process. If you've got children working rigidly in rows, then group work is very, very difficult. Whereas if you can move your tables so that children can sit in active social groups, then you can move between the groups. You don't have a formal place at the front of the classroom. And you can do your observing, you can gather your evidence, and you can intervene in real time. So think about how you even set out the architecture of your classroom. Formative assessment happens in very noisy classrooms. Not over noisy, but there's going to be some banter. There's going to be children talking. Don't expect it to be silent. In Max Science, we even encourage children to have their voice by using this concept cartoon style of page where we introduce 3 extra classroom characters. They say their piece. We think about what they've said. That gives us a platform to say our piece. So to encourage children to talk, we imagine, hey, these are the sort of ideas we want you to think about. So don't expect formative assessment in an active learning environment to be static. It's a very lively and loud and noisy and celebratory way of learning. And thinking about learning science. it's a combination. When you learn science, it's a combination of all of these activities, and they happen 2 or 3 times during a learning process. And there's a lot of talking and listening, both by teachers and by children. You may be measuring, you may be modeling. There might be more talking, more thinking, more testing, then more questions. And that process, articulating in circles, moving around the classroom in a dynamic way, will enable everyone to build understanding of a deeper nature. Children's voices are critical. Allow them space to speak. I was thinking of Tate's Maths, and where Tate has beautifully shown several ways, as Tony said, of making fives. Well, if only I could have listened to Tate, so Tate could have told me, what were they thinking of when they put the shells down? What was special about the way the shells were arranged? And I'm sure Tate will tell me, well, there are 4, first of all, and 5 is 1 more, or something like that. So listening to children's explanations to reveal their thinking, very, very important. Yes, I didn't want to lose sight of Miss Helpful. She's in the middle of all of this dynamic process. She's intervening. And as I've said here, when you do this, you are much more than the cabin crew. You are the pilot. Your job is much bigger than handing out rulers and scissors and counting them in and making sure everybody's busy. You are steering the learning. You're intervening. You're in the middle of the mix. So here you are gaining your real-time evidence to real-time observation. And you may want to intervene. You may say, this is interesting. I'll ask an open question. Open questions. Practice these, very powerful for formative assessment. Questions like, tell me about this experiment. Tell me about your results. What do you think about this method? Questions like that will offer you evidence. And of course, evidence from children's work in the workbooks will also give you an idea as to how people are progressing. So you might just want to walk through your classroom and look at the workbooks, look at the diagrams, look at the annotations, and think, can I move on with this group? Have we understood? How deep is the understanding? What do I need to go over before the lesson's finished? So that's real-time assessment, which influences your teaching there and then. So here is the notion that we are sharing this assessment, both maybe with other teachers, but certainly with the learners. We might share amongst groups of children, so they can actually take the role of teachers themselves. Sarah's good at explaining. She helps me a lot. You'll find that there are natural teachers within your student body. Some children just love to teach other children. Make the most of them, and also make the most of those interested parents, because they could be partners in formative assessment too. And as we've heard, parents taking a role in maybe sending in a video of children learning at home, or as we have a journal in the Max Science where we encourage the bridge to be built between home and school. Make the most of those links because they are your partners in formative assessment. Now we're going to talk a little bit about progression in science. When children grow, Tony will have seen this with his grandchildren, and you will have all seen this with the children in your charge. Yes, they get incrementally taller and taller and heavier in a sort of continuous way. You don't even notice the changes. However, when you're learning science, science is not smooth and continuous like that. Science is based on steps, conceptual steps. So think about this. When you're learning in science, some of your targets will be to move children up a conceptual step. So for example, it may be to understand how night and day works. That's conceptually very demanding, counterintuitive. We think the sun goes around the earth because that seems to be what happens. The idea of a food chain is a real conceptual challenge. So there you've got hurdles in science, and one of the challenges you have is to see what this hurdle is, to understand the nature of the hurdle and the misconceptions that children may be faced with, and that will become your target for teaching for the day or for the week. And it helps, I think it helps to think in like this. When children come into my lesson and when children leave my lesson today, in what ways will they be different by the time they've left the lesson? How do I want them to think differently? To what words do I want them to feel more comfortable with? What ideas do I want them to leave that they didn't have at the start? How will I have changed them? How will learning look like? What will it look like by the time the lesson's over? And that is a very important question to ask yourself before you look for evidence. Otherwise, you don't know what you're looking for. That evidence could come in a number of ways. And you are instrumental in helping children move into that, aha, I understand it now. That was the hurdle I was facing, and now I feel better about it. Ah, so that's how it works. How many times has that happened in your life? Ah, so that's how it works. That's your job, intervening with all of the skills in your toolbox, the poster sessions, the open questions, the scaffolding, the storytelling and modeling, all the things that you're very good at doing as a teacher. They're what you bring to play during this formative assessment stroke teaching episode to help children move through those conceptual steps. But you need to be aware that those steps exist. Let's have a look at a couple of skills in science. Measurement is one that we're all involved in. Measurement, of course, has a progression built in from, for example, in this illustration at the top left, just sequencing a group of pencils in a way that makes sense and talking about why we've sequenced them like this. I've put them here because on one side is the tallest, and then they get smaller and smaller and smaller. And this is my sequence. Or you may well want to use an instrument to find how long a pencil is. And the first instrument may well be one which is just whole centimeters. And then later on, you may well wish to introduce millimeters and a more complex measuring instrument. And that's not the sort of instrument you would use straight away. So think about, when you're thinking about conceptual development in science, when it's relating to skills, well, those skills both have to be taught, but there is a progression in the way that they develop. Much of our science is involved with looking for patterns. And those patterns are the stories that we might tell about some of the activities we've been engaged in. So we may well be collecting cans for recycling, and we've got a little chart here on the left of how many cans we collected on each day. And we could draw boxes, or we could draw the cans themselves in a sort of pictogram. They are discrete variables, 1 can, 2 cans, or 3 cans. We might progress to a bar chart, which is simply just taking that height of cans and making it into a bar, and the bars will have different heights, and that gives us a second variable. Both discrete, they're just whole numbers or whole days. Then progressing to a line graph where we may have continuous variables like the temperature that we are measuring of a beaker of water. Or we may want the length of a piece of elastic band as we're stretching it. And then eventually we may well look at something other than a straight line graph, and for older children, maybe asking them to draw a dot graph which results in a curve. Now, I've got these 4 diagrams here simply to illustrate that there is a progression in skills. And wherever you are with your learners, thank you, wherever you are with your learners, you need to know where in that continuum do you stand today. So what is your target for this type of skill or that skill? It's just as important as what is your target for this conceptual jump or that conceptual jump. So we're teaching concept and we're teaching skills. So think, what have they already done? What are the next steps? And then you plan your teaching accordingly. And that's what you're looking for, evidence, while you're formatively assessing the group's progress during this lesson. Well, we're coming to the end of this time that I've had with you, and I've tried to cover 3 basic areas here. I've looked at, rather like Tony did, the notion of formative assessment as opposed to high stakes assessment. I've made some comments about social learning and how one gathers evidence, particularly more easily with children in groups and by activating their voices, by learning to listen. I've mentioned progression in one's understanding, and the progression that we have in science is largely through steps, and the steps are conceptual, and each one needs to be understood by the teacher and planned for. And finally, skills progression is also something that you have to manage, and it's very important for you to understand the nature of the progression and to teach the topics before just assessing. There's no point in having an assessment if you can't look back and say, well, we've actually had some practice on this before I'm assessing. So many dimensions to assessment. Our time is up for now, and I thank you for listening. We'll have some discussion time, I think, and we've got about 5 minutes left. So I think a final slide is our closing slide for my presentation. Thank you very much for listening.
Thank you both. That was very interesting to hear the similarities. I think it's a lot of it. It works probably in any field that you're studying, that sort of formative and summative assessment. So we have got a little bit of time for questions. So if anybody would like to put something in the chat box or an observation, that would be great. Just to say that, first of all, thank you very much for joining us today. We will be sending out a copy of the slides, a certificate, and an opportunity to watch and listen again and share with colleagues. So any questions, Tony and Bob, very happy to take them.
Whilst people are typing, I thought that was really interesting what you were saying about listening, Bob. I think that's so important, isn't it? Because as teachers, we're so often bound up in thinking about what we're going to do next, that there's no space in our brains for listening to actually what the students are saying or thinking or doing.
And as a trainer of teachers, you will have come across many beginning teachers whose lesson plans are scripts for their monologues. And you'll know that one of the great challenges in the 1 year of training or whatever time you have is to move them away from that, to have the confidence to be listeners rather than presenters.
And part of that is our confidence in the subject, isn't it? So somebody who is a confident scientist can free up space to hear what the kids are thinking about science and know where to go next. And the same with maths, which is why subject knowledge is so important.
Yeah. But you don't need to have super masterful understanding, do you? You just need to know where the challenges are. And that's why research papers and small journal articles in science education or maths education journals, they can be very powerful to point you in directions of good teaching. I mean, I've got a lot of my knowledge from just listening to others and going to lectures, and rather like this sort of webinar, just thinking about what people have said. And over the years, you do get much, much more confident and much more powerful as a teacher simply by listening to others.
That's right. And somebody said in the chat whilst you were talking about learning alongside everybody being learners. Can't remember who it was. And that's where we develop our subject knowledge. As we are teaching students, we develop our own subject knowledge, learning alongside the students.
Yeah, and I mentioned that if you are a listening teacher, you will find ways that children explain things that you'll think, wow, I'll use that next time.
Yeah.
Well, it looks like people have been grateful for the messages that we've given them. Certainly, there's a very limited amount of information you can give only in 25 minutes.
Yes.
So both Tony and I have tried to give big picture overviews, hopefully with enough practical examples for you to take away and think about in the context of your own self-image as a teacher, because that's quite a difficult thing to do. And it is about thinking, it's about what was called reflecting in practice. It's about having almost like the thought bubble with you at all times as you're the teacher. What should I do next? And what are the signals? How am I performing as a teacher? And how am I doing as a learner even? So it's about thinking about what you're doing.
Tony, do you want to pick that one up, that question?
Yeah, I think it was Manu. Was it you, Manu, who was asking for videos from home? Because that was a really, really good way to observe students online. I think another possible way is if the platform that you're using allows breakout groups, to use breakout groups with the students so that they're engaged in a small discussion, maybe 4 of them engaged in a discussion that you can drop into as you might do in the classroom. Asking students to prepare presentations online, and they quite often quite enjoy doing that, where they might be working on a maths investigation or even a science experiment at home, and what they do is with their parents prepare just a 5-minute little explanation. I think those sorts of ways. It's obviously a little bit more formal than it would be in the classroom. The breakout room one is less informal if you can do. Okay, Manu, so maybe the idea of getting them to film some presentations.
I think, yeah, and I think also to invite children, they're very good at role-playing, children. They like a bit of drama. So if they've got a brother or sister or a grandparent or parent at home or guardian, and we could encourage them to become a teacher and to take a topic that they thought they didn't understand, but now they've really got it. Can they teach the person, the adult, whoever? And let's just a little video of them pretending to be a teacher, and they can wear a teacher's hat or they can wear a teacher's jacket, and they can become the teacher, and they can draw the diagrams to explain things. And of course, in engaging in that little bit of role play fun, what you will be doing as a teacher, observing the video or observing the live webinar, you'll be doing your own assessment. You'll be listening and watching, and the evidence will pour out in front of you.
It was Marina who suggested that, and I thought that was a really good suggestion. Marina was saying her last assessment was getting somebody to send a little video of them counting.
Yeah, and Nelia Velasquez has also suggested, let students be teachers, and that's the same idea. Yeah, both at home or in school.
Yeah.
I would also add that it actually makes you live longer as a teacher, because you're far less frantic at the end of every lesson, because your voice is still intact and your energy levels are still there. Because the people working hardest, and this is a very powerful message given to me as a young teacher, make sure that the people working hardest in your lesson, it's not you. Yes?
And it's those 2 points from Dylan William: activating students as learning resources for each other and activating students as owners of their own learning. Both of those things happen when you put students in as teachers.
Yeah.
Thank you all very much indeed. Thank you so much for giving up your time and joining us today. Thank you, Bob and Tony. Just really great information, and so informative. So thank you very much indeed. Thanks, everybody. And we'll pick that question up and get back to you on that one. Thanks very much. Goodbye, everyone. Enjoy the rest of your day.
Goodbye. Thanks, folks.